Hi everyone. So in this video I'm going to try to get a HDMI to CSI-2 bridge that I had bought a long time ago. I think I bought it back in 2017. But at that point I tried to get it working on my Raspberry Pi 3 Model B, and it didn't seem to be quite ready to use for me. So I put it aside and forgot about it. But recently I found it in my stash of modules, and I figured I'd try it again and see maybe in the past few years that things have passed, maybe the software support for it in the Raspberry OS is better. So and since then the Raspberry Pi 4 Model B has come out, and those are the only machines that I used it today. So I was wondering if this HDMI to CSI-2 bridge would work on the Raspberry Pi 4 Model B. The reason I wanted to use such a module is because I wanted to be able to feed some video by playing it on another machine and feed it to the camera interface and bring it into my OpenCV application, so that instead of looking at some live scenes, I could use it for maybe someday automating the testing of a OpenCV application by just playing canned videos that I might use for testing. Anyways, so I decided to try it again, and what I have, let me point to this setup first and explain what I have going on here. On this side, you'll see a Raspberry Pi 4 Model B that has a camera, that has this camera attached to it. And that camera is coming through this cable right here into its MIPI connector. So this is this machine. The name of it is RPi1. It is the target machine in my setup. On this side, I have another Raspberry Pi 4 Model B that has the Auvidea B101 HDMI to CSI-2 bridge. This is a 15-pin FPC model, so it's the B101, and it's I believe it's a Rev 4. What I'm going to do is I'm going to bring the HDMI output of this unit into this unit using this cable, this white cable that says RPi1. That RPi1 is this machine here, and here is the output of it, the HDMI output of it. It comes out of this machine over this white cable, HDMI cable, and then it comes in to this end of this cable, and it plugs into this HDMI connector that is on the Auvidea B101 module. On this module, there's a Toshiba chip that will take the output, the HDMI input at this point. For this machine, this is the input, and it will then convert it into CSI-2 MIPI, and it'll feed it into this second Raspberry Pi 4. Let me turn this around so you might be able to get an idea from the side profile. As you can see, I'm holding the input HDMI that's coming in, and you notice at the other end of the module, which is sitting above the Raspberry Pi 4, there's a short cable that will connect it to the camera input. If I turn it around this way, you'll see the view from this end. And as you can see, I have some standoffs in there to make sure that the module doesn't touch the Ethernet connector or the USB connectors and cause a short. But that those two stacked standoffs gives it enough space. It's a little wiggly, but it works fine as long as I'm careful and I'm not touching. But if I pull out the cable, it's a little bit too. I don't know. I have to be very careful pulling the cable out. So I'm not going to remove the cable at all in this video. One more thing you'll notice on this machine here, this is the viewer machine, I would say. This is called Raspberry Pi 2, RPi 2, and I don't have it connected to a HDMI monitor. What I have is I have an HDMI dummy plug attached to it, but this HDMI dummy plug, it is using a full width HDMI connector. So what I'm doing is converting it using this other cable to the mini HDMI that is that mini HDMI? Hang on, sorry. That's actually micro HDMI on this side. That on the Raspberry Pi 4, the HDMI connector is micro HDMI. So this cable, this one, that one's power, USB-C. This is micro HDMI on this end, and it connects to this HDMI dummy plug. This is a 4K HDMI dummy plug that I bought from Amazon, and also this other cable, the micro HDMI cable to HDMI adapter. I also bought it from Amazon. I'll have the links in there, but I do need this because I don't want to have a monitor attached. Both of these machines I'm going to remotely connect to their desktops, so neither one of them has a HDMI monitor. And as you can see, there is no USB attached here. Although there is USB attached right there, I don't really need it because I'm going to be connecting through VNC. All right, so that's what I wanted to point out about the hardware setup. Let me give you a little bit of a couple of web pages that describe this particular HDMI to CSI-2 bridge. So as I mentioned, the product is the B101 HDMI to CSI-2 bridge 15-pin FPC, and this is from Auvidea, AUVIDEA. The website is auvidea.eu, and if you go to this link, you'll be able to find this page. It's about 70 euros plus shipping and taxes and whatever. And I believe the latest Rev is Rev 4, which is what I have. And there's a description here about the technical details of it and how, as you can see, this is connected the same way that I have it. This is pictured with the Raspberry Pi 3 or 2 actually. And so the product is kind of old, and but it seems to be, well, I wanted to see if it works, and it seems to be working for me a little bit enough. I'm not quite comfortable for the way it works because I'm not familiar with it yet, but it seems like it's hopeful, and I may be able to get it working better for me for the desired application that I have in mind. But anyways, if you go to the Auvidea page, website, if you go to the home page, what you'll see under products is CSI-2 bridges, and it is this one, which is the 2-lane 15-pin FPC, because the Raspberry Pi CSI, the MIPI connector, that is a CSI-2. It only can support 2 lanes. So it's the B101 that is compatible with the Raspberry Pi. By the way, this may be compatible with the Jetson Nano development kit too, but I'm not sure. I haven't tried it myself. In any case, from there you can come and find this page as you saw me navigate. There are a couple of different pages. This is a PDF document that describes the board. There's all of these different boards that they have. B101X HDMI to CSI-2 bridge. So again, that's for Rev 2 and 3. This is Rev 3.1, and then Rev 4. This is the Rev 4. I think that it looks different in this picture, but I believe it's same. But anyways, there's also these other products that they have. And then at the bottom, yeah, they have different products, and there's some useful information in this document. There is also this page on auvidea.eu where it describes how to install the module on a Raspberry Pi 2. It doesn't really seem to have changed much. The only thing is that this describes testing it with the Raspberry Vid application. I wasn't able to get that to work, and so I'm going to use GStreamer and Uv4L2, but I couldn't. I got an error when I when I tried to run the Raspberry Vid application. I believe okay, well, I believe that it just says that something about not being supported in the firmware, so you may need to. There is no apparently there's no firmware, or at least I don't know what the status of the firmware is. So I started searching the Raspberry Pi forums, and I came across this thread, which is fairly recent. It's actually from 2018. It started in 2018. It's topic 216903 about Auvidea B101. And here's the error that if I try to run Raspberry Vid, it gives this error. The driver for the TC358743 HDMI to CSI chip you're using is not supported. They were written for demo purpose only, and then something to do with a firmware, check for a firmware upgrade. I didn't want to follow that because I'm not sure if there is really a firmware upgrade. So as I started reading this thread, it became clear that there is one option there is one driver called the Uv4L driver that was discussed in this thread. At the end, a lot of this thread is talking about Uv4L, but then later on, you come into this. I came across this this comment, and this is significant. This is actually from 2019. It's by 6x9, who is a Raspberry Pi engineer and a forum moderator, and who seems to be quite involved with the camera drivers and modules for the Raspberry Pi. And as you can see, 6x9 user said, sorry, I don't provide any support for Uv4L. I then realized that, okay, maybe I should just listen to what he's saying, or he or she, and and I went with, started looking at what it was saying, and then it describes that that the kernel 419 apparently has support already for this module, and with Uv4L2. So it describes listing the device here, and if you list it with that command Uv4L2 control list devices, you'll see that a unicam camera is detected, and if that works, then that shows that the Raspberry Pi OS and the kernel have detected the Auvidea B101 module and installed it as a unicam camera. And that is I think the driver for the TC358743. And in this post, 6x9, user 6x9 explained how you can install, how you can enable the driver for this module is basically by editing the boot config.txt file and adding this overlay. This will tell the kernel to load this the driver for this chip, and that's what makes it work. If you're using a Raspberry Pi 3B or 3B Plus, there's a separate instructions. But for my Raspberry Pi 4 Model B, I used this instruction, and I added this to my boot config.txt. And when I booted it, I issued this Uv4L2 control -- list devices, and I was able to see the unicam camera working. Being detected. So that's great, and that gave me some hope that at least there is support in the kernel for it. But then there's it explained that I need GStreamer 1.10, and apparently at the time when this post was made, maybe you needed to run a script to build GStreamer 1.10, but that's not necessary anymore at this time. And I was able to install the GStreamer 1.10 tools using the app package and get those tools working. So this was a really big help, because then I didn't need to use the Uv4L driver. Instead, I used the Toshiba 358743 driver with GStreamer. Well, since my OpenCV application can use GStreamer pipelines, that seemed to start to bring me closer to where I needed to be. There are a few comments afterwards, but then I went and read all of these things that the user 6x9 had posted in this thread, and I came across this, which says on each boot you need to provide the B101 with an EDID file so that the HDMI source knows what resolution and frame rates are supported. That was great, because in the next sentence, user 6x9 says that there's a suitable file, EDID file, it means, at this address, at this GitHub repo that belongs to 6x9. And I can go there, and if I click that, I will come across this EDID file that user 6x9 has provided in his, I'm going to assume his repo. There is a repo YAVTA. I believe it's, oh, I don't know what it means, but I think it's yet another video something. But here's the 1080p 50 EDID text. Now, I have no idea what the content of this EDID file is, but so it was great that there was at least something I could use to get started, well, get going further. So that was a significant comment that I came across, and it was useful to me. User 6x9 described other things like this. It says you also need to run V4L2 control --set dvbt timings query before running GStreamer or FFmpeg. This sets the resolution to that detected at the HDMI input. Neither support automatically setting the timings nor changing them should the source change. And then here's a useful example GStreamer launch command, which I didn't try actually, and I should try it, but anyways, I stopped actually at about here, so I haven't tried this recommendation, and I haven't tried this one, and I probably should, but I haven't yet. But so again, maybe some of the results that I'm getting, I would get better results if I did follow them, but I will get to those eventually. And this is sort of at the end of the thread, so I found this thread to be very useful, and it helped me a lot. So it helped me not go the Uv4L direction, which should also work apparently, but I wasn't as familiar with Uv4L as I am maybe with V4L2. So I would highly thank the user 6x9 for all the useful information that he provided in this thread. But there's a bunch of threads. There's a new, fairly recent one, describes an error, the error that I was describing before. But then this is with Uv4L, so I didn't look at it that much. The rest of the threads that are on the Raspberry Pi forum about this topic date back to 2015-2016 timeframe. And it seems like there was a lull from 2016 till about 2018, or at least I haven't come across any other threads. But anyways, this was pretty good. So with the information I got there, I was able to get a little ahead. So I'm going to now show you some of the procedures that I was able to get working. So if I switch back, you see, let me shift this a little bit. You see in my background, I have the viewer Raspberry Pi 4, and it's connected to the other one. Now, the lights are off. So what I'm going to do, there are no blinking lights. So what I'm going to do next is turn on this unit, the viewer, the ARPi 2. So that comes on. So as you can see, the lights are on and it's booting, and it will, that's ARPi 2. I have the VNC session here, and I'm going to wait for it to boot up. It takes a little bit of time. Okay, so ARPi 2, which is the viewer that has the B101 module attached to it, is running. It's at desktop. So one more item that I picked up from the forum thread was that we need to configure the Raspberry Pi for 256 megabytes of GPU memory. Since the Raspberry Pi 4 Model B that I use has 4 gigabytes, this actually is workable because I have enough memory to be able to give this chunk of it to the camera, and this is what's needed to make the HDMI capture using the CSI bridge smoother. I guess it works, but it could drop more frames if we don't set it here. So I just wanted to point this out as well. What I will do is I will open a terminal, and what I want to do is to make this window a little bit, zoom in a little bit more. So now let me make it also bigger. So I'm going to recall this command here. It's the Uv4L control. This is the one that I'll use to load the EDID file. Set EDID set EDID, and then for the file, I will provide the path to where I cloned the GitHub repo from 6x9, user 6x9, the YAVTA, where the EDID file is. So I've already cloned it using just a command line git command, and it's at that path. And then the rest of the command is --fixed EDID checksums. So I'm going to execute this command, and this will tell the module B101 the information it needs about its formats and so on. And this is the output that the command will provide. So at this point, I'm going to turn on the other Raspberry Pi 4, the Pi 1 in this case. So as you can see, the lights came on this one, and it is also booting, and it will take a little bit of time to connect. So I'll pause and come back when it's connected. Well, I guess in the meantime, what I can do is I can execute the command, and as you can see, Uv4L control list devices on my system is showing a Unicam camera as video /dev video 0. So that's working. Also, keep in mind that the MIPI cameras have an I2C interface for controlling the camera. So if I look at the I2C devices, what I'll notice is there are two I2C buses. This I2C bus is the regular I2C bus that you'll see when you boot up when I boot up my Raspberry Pi 4 Model B without the B101 module attached. But with the DTS, I'm sorry, with the overlay added to the boot config.txt, and after I've enabled the Unicam driver, I'll end up with two I2C buses. I2C-0 also appears. So it's a lower number, but it's the one that comes in if enable the Toshiba driver. So if I look at that bus, I will see that a device at address 0f, hex 0f is been detected, and a driver for it is taking ownership of it, so it's marking it as UU. On the other bus, on bus 1, I have my real-time clock on that bus. This is the subject of a previous video. But so this bus is normal. This I2C bus is normally there. This is the extra bus that I get when I enable the module from Auvidea. So that's kind of what I wanted to point out. Also, if I grep the message for the TC, as you can see, TC or I2C, you can see that in the message that the TC358743 driver found. It says it found at 1E. It's showing found 1E at F, so I'm not sure what that is. It's what this means. It just says I found at 1E. Okay. So okay, so by now the other Raspberry Pi, the target Raspberry Pi, has booted, and it's booted into its desktop. Because of the EDID file that I am using, what it does, the desktop comes in at 1280 by 720 resolution. So if it's smaller than full screen, but I've enlarged my VNC screen, so it's showing it full. But let's go to this side and to the RPi2, which is trying to monitor and view RPi1, and see if we can see the desktop of RPi1 through RPi2. Now, one of the things that I mentioned I haven't tried from the comments from user 6x9 is this command, and I'm going to try it now just on the fly because I believe it might resolve some issues that I was having in my procedure. So I'm going to try this and see if it works. So what it says is Uv4L control --set -dv -bt -timings query. It says bt timings set. So now what I'm going to do is I'm going to try and run my GST launch command. So in my GST launch command, I will say that the source is Uv4L, the device is the Unicam driver, and then because I know the other machine, the target machine is running a desktop at 1280 and 720, I'm going to provide those dimensions. And as far as frame rate, what I've seen in the comments is that there's the module is limited to 24 frames per second. And then I'm going to convert and then pass it to auto video sync. And let's see if this will work. And there you go. Yeah, it looks like it's working. And executing this command here helped resolve some of the issues that I was seeing before I started to record this video. I had found a workaround, but it looks like by executing this, I don't have any trouble. And here I am able to see the desktop of the other machine I'm able to see its, let me see if I can show some. The other machine is RPi1. The target machine is RPi1, and I'm looking at RPi1 through RPi2's camera, but there is no camera attached to the Auvidea HDMI to CSI bridge. So now I'm able to, as you can see, I'm moving the mouse on my VNC screen for RPi1, and I'm able to view it live on RPi2. I can open a terminal. Is typical. I type a command and you can see it. As you can see, it is pretty responsive. I'll run the top command here, and it looks good. So you can see how responsive the video capture is on RPi2 as it views RPi1's desktop through the bridge, the HDMI bridge. Okay, that's fantastic. That extra command helped a lot. So next, what I'll try to do is to see if I can run my own time exposure application, which is an OpenCV application, and see where I get with that. Okay, so again, we're looking at the desktop of RPi2, which is the viewer machine, and it's able to see the desktop of RPi1, which is this scene here. And as I open a terminal on RPi1, as you can see, this is the desktop for RPi1, and this is the desktop for RPi2. So that's pretty smooth. I'm going to apply the zoom, and you can see that that it's pretty responsive. So now, the next thing I'm going to do is I'm going to run my time exposure application, sample application on the target. This is an OpenCV application. It'll open the camera, as you can see. And now the camera of RPi1 is capturing this scene, and it's looking at the jumble of cables and cameras and things that are on my workbench here. And I can start capturing, and now on the right is the live view, and on the left is the time exposure. And if I move my hand in front of the camera, you see that nothing shows up on this side because I don't hold it there for 10 minutes. An object has to be in the scene about 10 minutes before it registers. But you saw that some of my outlines of my finger did get captured because it was in the scene for just a little bit, and then it goes away. So anyway, so that view, what I was doing that on RPi1, but RPi2 is able to actually see all of that and capture that scene using its HDMI to CSI-2 bridge. Now, if I can feed that into the same application running on RPi1, that would be good. That would be the objective that I have, is to be able to take the input from the CSI-2 bridge and give it to my application. Okay, so I'll try again, and the path is bin cv timex, And now I'm running the same time exposure program on, and it doesn't seem to be able to open the camera, the Unicam camera, for some reason. Okay, so that was the thing that I was hoping to be able to do, is to be able, well, of course not. It won't be able to, because I'm using the camera right here in this window. So I have to close that. So my G streamer is not using video 0, the dev video 0. Okay, so let's try again. And now, yeah, there you go. Now I have the output, the desktop of the other machine coming into my OpenCV application, and I'm watching it do the time exposure. Now, this is the same time exposure application running on ARPi2. So if I start capturing, ARPi2 is now doing its own 10-minute time exposure of whatever it's seeing from the other machine, which is awesome for me, because that's ultimately what I want to be able to do, is to really play a video on one machine, feed it into this application, and have this video, this application do its task, and be able to do that with, you know, for during an automation of the testing of the application. So it looks like I'm in good shape. I might be able to actually use this module for automating the testing of this application. In addition, I mean, with the latest COVID-19 restrictions and being at home, a lot of people started doing streaming, and some of the streaming equipment got very expensive. I remember I bought a couple of game capture devices prior to the restrictions, and the prices were pretty normal. But during the shelter-in-place order, I saw that at times the prices of these capture devices would be way up there. Well, with this module, it's possible to turn a Raspberry Pi 4 into a capture device then. Of course, you would have to know a little bit about programming and or using GStreamer or Uv4L2, but it looks like the hardware is there for a game capture device, and the lag is pretty reasonable. I think the delay, I don't notice any lag. At least I don't. It's responsive for what I have in mind. But what you can see, if you already have a Raspberry Pi 4, which you've paid for before, you want to turn it into a capture device, then this is about $70, 70 euros plus tax and shipping, versus maybe a couple of $100 for a game capture device. So I don't know, you know, I fortunately have bought all the equipment I need for capturing these scenes for the YouTube videos before the shelter-in-place orders. But I wanted to just point out that that's another application for this module. Anyways, I hope this was useful, and you know, hopefully as I get to use it more, I'll be able to post some more results about it. Take care, and I'll see you in the next video.